Hey there, John here. We covered a lot of entries over the last 3 videos with the AI Tweaker section. If you thought that was a lot, strap yourself in because the advanced section has even more options. So let's go ahead and get started. We're going to start with the AMD fTPM configuration. The AMD fTPM switch allows the user to enable or disable AMD CPU firmware TPM. TPM stands for Trusted Platform Module. It is a chip on the motherboard that allows for more robust disk encryption without requiring extremely long passphrases, for example, BitLocker. A TPM generates encryption keys, keeping a portion of the key itself. This prevents an attacker from removing the chip to gain access or from removing the drive to gain access. The next item is Erase fTPM NV for factory reset. I believe NV stands for new value, or in this case, a new CPU. So, for example, if the user changed the CPU, even with another one of the exact same type, in this case, say one 5600 for another 5600, disabling the switch will allow the user to boot up the system, but fTPM will not be enabled, and there will be no access to the encrypted data. If enabled, the user will need a recovery key in order to boot into the system. Next up, we have CPU configuration. So the information at the top just provides some general data on the processor. See, we got a 5600 6-core, what speed it's running at, voltage, max speed, the microcode patch level. I have no idea what that is. I don't know if that has to do with the AGISA or not. And then the cache per core. And then we get down to PSS support. PSS support stems from ACPI, and ACPI stands for Advanced Configuration and Power Interface. Enabling this switch allows for various power-saving features to be active. Disabling the switch could provide more overclocking stability, as the system will not be looking to save power. You can see the options here: enabled or disabled. Next up is NX mode. NX stands for no execute. It is a technology used in CPUs to segregate areas of memory for storage of processor instructions, i.e. code, or for the storage of data, which is the typical use for memory. This is substantially similar to Intel's XD bit, which is execute disable. It is a security feature to prevent malicious code from taking over a system by inserting its code into another program's storage area, which is kind of scary to think about. Next up on here, we have SVM mode. Enabling this switch allows the user to enable virtualization. Why would you want to do this? Well, you may want to run Windows 95 or Windows XP, but you don't want to uninstall Windows 10. By using virtualization, you could have a virtual machine, quote unquote, running these older operating systems alongside Win 10. This could be useful if you have a very old program that requires an older operating system. And I'm sure there's a whole bunch of other use cases for virtualization. That was the one that came to my mind. SMT mode. SMT represents simultaneous multi-threading. A Ryzen 5600X operates with 6 cores and 12 threads. Disabling this feature forces the processor to operate only as a 6-core and 6 threads. It should also be known that if SMT is disabled, the S3 power state, which is sleep mode, is also disabled. And then the last one here is we have core leveling mode. This allows you to manually dictate how many cores the system will use. Again, if the user changes the number of cores available, power state S3 is disabled. I have no idea why a user would want to limit the number of compute units in their systems. The options are 2, 4, or 6 per processor. Actually, in this case, it's 1, 2, 3, 4, or 5, since I have the 6-core processor. Next up, we have SATA configuration. I say SATA. Do you say SATA? SATA? Always wonder. I say SATA. During setup, the BIOS will look to see if there are any SATA devices connected. If not, not present will show up in each of the respective ports. So the first up here is SATA port enable. Enabling the switch allows the user to access various configuration options. If it's disabled, then we don't. So the next one on here is SATA mode. Choices are AHCI or RAID. AHCI stands for Advanced Host Controller Interface, whereas RAID is Redundant Array of Independent Disks. And it's just the manner on which the hard drives are formatted to run with your system. Next up is NVMe RAID mode. Enabling this switch would allow the user to utilize RAID for their NVMe devices. Next is the Smart Self-Test. If this switch is on, it will allow the BIOS to run what's known as the Self-Monitoring, Analysis, and Reporting Technology, stands for SMART, system, which will display a warning message during post if an error occurs in the hard disk. Next up, I have SATA A6G1. And if I click on that, it would allow me to rename the SATA port. I would presume this allows the user to more uniquely identify the specific drives that are attached to each port. For example, you could have one named media, another one named work data, another one personal data, games, etc. And that may make it easier for the user to manage and oversee the various drives that are connected to their system. Next up is hot plug. If the port is configured as AHCI, the user has the ability to enable hot plug use for drives connected. If the drive is set up as hot plug, it would allow the user to remove it similar to a USB stick. While you could not do this with the drive on which the OS resides, a user could remove data drives and make them portable. I only have the one, and it is my OS, so I have that disabled. And then as you see, the rest of the SATA connections all can be done the same way. If I have anything connected to them, I could rename them, and I could use them as hot plug or not hot plug. And then next up, I have the M.2/1 and /2 devices. So it's interesting because my M.2 drive is enabled as AHCI, it doesn't show up here, and it shows up as not being present. But again, I can rename them, and then any options that I have that are available with them would be there. Next up, we have onboard devices configuration. First thing is the HD audio controller. Many motherboards have audio controllers included with them, and enabling this switch allows the user to use the motherboard's built-in high-definition audio controller. Next up is the PCIe X16 mode. This allows the user to set the speed of the PCIe X16 port. In this case, I have mine set to auto, but you could have it set to Gen 1, Gen 2, Gen 3, Gen 4. As an example, on a system that I built for my son, it has a riser cable in order to connect the GPU. And while the motherboard is the exact same as this one, is set up for Gen 4, and his graphics card is a Gen 4, the riser cable is only Gen 3. So on his BIOS, I have this set to Gen 3. On this particular one, I have it set to auto. I have an old 1070 connected here. So I don't even know if that's Gen 2 or Gen 3 at this point. So I just have the BIOS doing auto. Next is the M.2-1 link mode. And this allows the user to set the speed for the M.2-1 device. And again, it could be Gen 1 through Gen 4. Next up is the SB link mode. And again, we have Gen 1, Gen 2, and Gen 3 only on this one. And that's because with the B550, I believe the Gen 4 is the connections to the direct connection to the CPU, where the chipset itself only has Gen 3, whereas if you got the X570 board, that has I believe has Gen 4 availability from the chipset. But in this particular case, again, SB stands for Southbridge, and it allows users to set the Southbridge link speed for those devices and peripherals that are connected to different parts of the system. Then we have the M.2-2 link mode, same as the first slot. And then we have the PCIe X16 bandwidth bifurcation configuration. So here we could have it as either auto mode or X8 by X8. This allows the user to change the bandwidth of the PCIe X16 socket to allow for a carrier to be installed into the slot. It could either be 2 independent 8-lane devices or the standard device. Some other motherboards will also allow this to be in RAID mode, but for this motherboard, it's just either the 8x8 or auto. Next up is the LED lighting, and I believe this is similar to the Aura. So you have the option of all on, which means all the lights will be enabled at all time. If it's in stealth mode, all the LEDs will be disabled. If it's Aura only the Aura LEDs will be enabled, and all the other functional lights within the system will be turned off. And if you have Aura off, those LEDs will be disabled, but otherwise the functional LEDs will still be enabled. And then you have the same option for if the system is sleeping, how do you want the lighting? I have my lights on all the time. Next up, we have the Intel LAN controller. This option enables or disables the built-in Intel LAN controller. The user could disable this if they had another controller via an expansion card installed, or if they didn't have Ethernet access and were only using Wi-Fi. And then speaking of Wi-Fi, we have the Wi-Fi controller. Same as above, this entry allows the user to enable or disable the onboard Wi-Fi controller. And once again, same thing with the Bluetooth controller. Then we got USB power delivery in soft off state. This goes back to ACPI. The ACPI protocol defines all the different power states. There's S0 through S5. S0 is normal, powered on state, while S1 through S3 are various types of standby/sleep states. S4 is hibernate, and S5 is soft off. This entry allows the user to choose whether power will continue to be supplied to the USB ports while the system is in this state. So we're going to stop here. We got through the first 4 sections of the advanced. We have a lot more to go through, and this may take at least 2, possibly 3 more videos, depending on how much material I can get through in each video. But hopefully you're finding the information useful and educational, and I hope to see you back in the next one. Well, it doesn't take long to see that many of these settings are not related to overclocking. It's amazing how far personal computing has come and the plethora of options that are available to the user. We still have a lot to cover. You could also check out my website as I continue to build a BIOS glossary for a convenient reference. If you're finding these videos useful, please consider liking and subscribing, and I hope to see you in the next one.